Overcoming PCO, posterior capsule opacification, remains a major issue. I believe that a solution lies in improving surface modification of the intraocular lens. In this regard, I'd like to talk about a study which I've carried out in collaboration with Hoya Surgical Optics R&D section, aiming at better IOLs in the future. PCO occurs postoperatively when lens epithelial cells, or LECs, left over near the equator of the lens capsule, proliferate from the periphery towards the bottom of the lens. A recent solution is the introduction of square-edged intraocular lenses, which cause the capsule to bend, wrapping tightly around the edge of the IOL and preventing LECs from migrating into the posterior capsule. However, even if the square-edge lens is initially successful, PCO may still appear as a problem a few years post-surgery. Careful observation shows cell proliferation is maximal around the optic-haptic junction. This may be because a true square edge at the optic-haptic junction is difficult to achieve, which affects the efficacy of capsular wrapping around the edge of the IOL. In other words, reducing effective capsular bend in the long term. It's clear that PCO starts from the optic-haptic junction, but what to do? Could we somehow improve adhesion between the IOL and the capsule here? Could we change the properties of the IOL itself through surface modification? Surface modification includes chemical modifications of surface material to add new properties, or coating the IOL. Our idea was to modify the surface of the IOL only, increasing cellular and tissue adhesion but leaving the base material unchanged. To do this, we proposed treating the optical surface of the IOL with UV ozone. Here we see the situation right after UV ozone treatment. Adhesion is greatly improved, with the effect of optimum control of PCO. I've been testing UV ozone-treated IOLs in rabbits, comparing them with untreated IOLs since 2007. This is 2 weeks after surgery. While LECs proliferate noticeably into the posterior capsule from the untreated lens, we see no significant PCO with the UV ozone-treated lens. In addition to photographing the anterior eyes, I also analyzed them histologically. These are the tissue sections of the central part of the posterior capsules of the non-treated and UV ozone-treated IOLs respectively, 2 weeks after insertion. With the non-treated IOL, the LECs proliferated and migrated, suggesting advanced PCO. But the UV ozone-treated lens controls PCO very well. Repeated testing has confirmed these results. In 2009, we proceeded to clinical trials. Inserting different IOLs in the same person with consent made comparative study possible without having to account for individual differences. Clinical trials were completed in 2011, and we are currently following up. Only the posterior surface of the IOL was treated. Consequently, the cell adhesion is weak on the front of the lens, but very strong in back, facilitating capsular bend and improving the optic-haptic junction. Here are the results 3 years after the clinical trials. With the non-treated lens, you see considerable PCO. However, with the UV ozone-treated lens, little PCO can be seen. Here's another example with almost identical results. Attempting to evaluate the degree of PCO production objectively, I calculated PCO values using EAS1000. By these measures, the opacification values for non-treated lenses clearly increase over time. However, surface modification of IOLs with UV ozone treatment just as clearly inhibits this increase. I also compared the PCO values relative to the optic-haptic junction and a region 90 degrees distant where the square edge effect is considered optimal. The diameters of the measured regions were less than 2 millimeters. As expected, there is a lot of PCO with non-treated IOLs near the optic-haptic junction. However, with treated IOLs, PCO is low, even in this critical region. We believe that surface modification of IOLs is a major step forward in dealing with the problem of PCO. However, future IOLs, such as multifocal and accommodative IOLs, are being developed to offer improved visual performance. With higher performance comes the need to better control issues such as PCO and offer our patients better quality of life in the long term. Better IOLs. Fewer problems. Research into overcoming PCO has really just begun.